UN SDG Perspectives, organized by Lord's Institute of Engineering Technology, Hyderabad, and sponsored by AICTE-ATAL from 15 June 2025 to 20 June 2025. So let us start the first session of the first day of this FDP. Dr. Abhaykumar M. Kuthe sir, who is working as a professor in the Department of Mechanical Engineering at Visvesvaraya National Institute of Technology, Nagpur. He has completed his Bachelor of Engineering from RTM Nagpur University in 1986. He has completed his Master of Engineering from IIT Roorkee in 1990 and also PhD from RTM Nagpur University in 2001. He has overall 32 years of experience. He is working as a professor as said. His research focus is on 3D printing technology for engineering and medical applications, including customized metallic implant manufacturing. He also worked as a head of the department at Visvesvaraya National Institute of Technology, Nagpur, also a senior software engineer at Birla Consultancy Services, BICS, and also an engineer at Hindustan Aeronautical Limited, Nashik, India. He has 55 publications in various reputed journals, patents, book chapters, and paper published in Web of Science, Scopus, and other journals. We welcome Dr. Abhaykumar M. Kuthe sir as a speaker for the first day of Forenoon of this faculty development program. I request all our participants to please welcome him with a huge round of applause. Welcome you, sir. The session is all yours.
Sure.
Thank you.
Thank you. Yeah, I will take care. Thank you. So it's 5 minutes to 12, so still good morning, and really happy to be with you as a very first speaker, and I'm a bit under tension. It's like an opening batsman in a cricket team, and if he fails or if he gets out in the first ball, even the whole team gets shattered, and therefore I have to be very, very careful to deliver this particular lecture. But thanks to Lord's Institute of Technology for inviting me, and the topic or the so-called theme they have selected is the medical application in 3D printing. That itself is very catchy. I'll tell you why. Because 3D printing is not a new thing for the engineering students, and everyone has used this 3D printing, or rather learn about this 3D printing a lot. But yes, it's something new for the doctors or the medical domain, and therefore how exactly we are going to look at this particular so-called FDP from the point of view of medical application is a billion-dollar question for us. And I'm going to talk about my experience in this particular medical domain as a mechanical engineer. And you know, when I used to work in this particular field of medical application of 3D printing, and in the family when I used to talk about that this is how the thing is changing and all, many relatives, those who are earlier to my age, they say that when you have passed your MBBS, have you passed the MBBS? I said no. Then how come that you are talking about this medical field? So I think that's how exactly I started rethinking that are you capable of entering into this field where the human value is very important. And you know, there are n number of things I can talk about, but let me tell you an interesting thing here, that this additive manufacturing, to which we also call the 3D printing, rapid prototyping and all the names, actually helped medical professions to excel. So it is not that we are replacing the medical professions, or rather we are taking their role, but we are rather helping them in excelling. And you know what does the excel means? It means that whatever the doctor does, he is actually delivering the perfect result. And that perfect result means everybody is healthy. That's how we have now seen in the use of additive manufacturing in biomedical field. So let me talk about our CAD/CAM center where we are working, and you can see the two big bowls hanging there. One is called BETIC, to which we call it the Biomedical Engineering and Technology Innovation Cell, which we run under the guidance of IIT Bombay. And then there is another one called the Smart Foundry. So this is related to the manufacturing, how smartly you manufacture the product, especially from the medical domain. And what I'm rather trying to do is to see that how best we can help the medical professions. That's what I already said. So this is actually these two boards or what which I'm talking about. And I'm going to talk about how we are clubbing, or rather how we are using this boutique and smart foundry to help the medical profession. Now it's my standing invitations to all of you. It's an invitation that please do come and see the what exactly we are doing in this particular domain. And I'm going to talk about whatever we have done. And that's what I always used to say. It's like an interdisciplinary research, amalgamation of engineering and medical. And how best we are doing it in the CAD/CAM center, it will be quite interesting for you to see by visiting. And I always like the advertisement of घड़ी डिटर्जेंट ठीक किया, you know, पहले इस्तेमाल करो फिर विश्वास करो, like that. Please do come and see whatever I say today, that whether we are really practicing that thing in the CAD/CAM center or not. So please do come. This is the outline of my so-called speech, and I'm going to quickly finish everything because I think after my speech there is a lunch, so everybody must be waiting for the lunch later on, so I should not see that you will be late for the lunch. So let's start with the introduction. You know, 1991 everybody is aware of. That's where the liberalization policy has been started. And in this globalization, there's an impact in almost every sector. But you know, the 2019 was a new, has started a new era where we started talking about Make in India. Now see the difference. In 1991, we talk about the globalization. That means the whole world is together. And in 2019, we say that Make in India. That means we'll do everything in India and will not look at the world. So it seems to be somewhat contradictory. But it's not like that. Let me quickly tell you that when we talk about the Atmanirbhar Bharat or Make in India perspective, so there we are talking about getting the any product manufactured in India which will stand the global competition. And that's how exactly we'll have to look at. And I hope this particular picture is very clear. There we say that we have to talk about the premium quality of a product which will be sold all over in the world, and but it has to be manufactured in India. So you know, there is a lot of responsibility on our head or our shoulder to see that whatever we manufacture, it has to be sold not only in India but all over the world. And that's what exactly the Make in India concept talks about. Now, you know, the globalization and Make in India is really very tough. Why? Because you know, every sector or every product has already established their brand. Now, if you say that a car is from Germany, so you say that yes, it's wonderful car, made in Germany, wonderful car. Say some electronics component from Japan, you say, oh, wonderful, must be a very good. So that means talk of any hardware, and every country has established its own impact or the so-called their brand. Now, if you think about India, which hardware you feel that yes, it is manufactured in India, and the people are saying that if it is to be used, it has to be from Make in India. Now you must be thinking about that, which hardware. Now that itself shows when you are thinking about which hardware, that means we are not already established. Otherwise, you would have said, sir, this slide changer is so famous in the world that everybody says that if slide changer has to be used, it is to be from India. So you are taking some time to think about a particular hardware which will be manufactured in India and acceptable all over the world. That means there is no hardware which has established its brand. You may say that we have excelled in IT, we may say that we are very good in food and whatever it is. But how far the people are accepting your hardware in the world, that matters, and there exactly we talk about a concept called developed country. Name a developed country, you will find that they have established their credentials. For example, if you say that USA is a developed country, immediately you say that the Boeing planes are manufactured in US. No one can manufacture the planes other than the Boeing, though there is one company in the France, but they have established them. I already told you about the Germany, I already told you about the Japan. You know, if I ask you a simple question, what about a New Zealand? Whether New Zealand is established, whether it is a developed country or not, they say, yes, sir, maybe developed country, it has to be developed country. Yes, they have established their credentials in the dairy products. So, you know, all these developed countries have already established their credentials in the hardware, and there we are lacking. And that's how this particular concept, whatever we talk about Make in India or the so-called Atmanirbhar Bharat, it's tough to handle because you will have to develop a product which will stand the global competition. And when you talk about the global competition, see the other part of that, it has to be a premium quality product. That means the quality has to match with the international product, or maybe an innovative product which is not at all available anywhere and you are entering into that particular domain. So, you know, that's why I have just put that smiley. I'm unable to understand what is this Atmanirbhar Bharat and all that. But I think with this particular introduction, you are already aware of that. Now, next interesting thing is about this industry 4.0, 1.0, 2.0 and 3.0. I hope everybody is aware of that. Now, very simple question. You talk about industry 4.0. Those who are already completed their Bachelor of Educations in Engineering, and especially mechanical engineering, can I just recall that have you studied anywhere in your course curriculum first the industry 1.0, then 2.0, then 3.0, and now 4.0 has come? Is it like that, or you have learned first the 4.0 and now you are looking back about the 1.0, 2.0, 3.0? Answer is this. No one has taught you about 1.0, 2.0, 3.0. But you first learn about the 4.0. And then you started thinking about what is 3.0 then, what is 2.0, what is 1.0. So it is reverse way. And electronics and automation. And 4.0 they talk about the cyber physical world. Now, when you are entering into this domain from 1.0 to 4.0, you will find that the degree of complexity increases tremendously. That means 4.0 is very complex compared to 1.0. That's true. Now, whenever anything becomes complex, to whom you approach, the industry people, they are finding the whole thing complex. Then, to whom they will approach? They will approach to academic institute, and that is true. That if the thing has become complex, then it is the academic institute who is going to help the industry, and that is bound to happen. So here If you look at this particular our academic institute, to which we call as a College of Engineering. So 1.0 to our College of Engineering, there were some gap, and we always used to talk about there is hardly any academic industry interaction. And then you go on blaming industry go on blaming academic institute and all that, and both of them are in a comfort zone. Okay. But as soon as you enter into the 2.0 to 3.0 to 4.0, you see that no industry can perform without the assistance or without an association from academic institute. No, even academic institute cannot progress without the association with the industries. And that's how the whole thing has changed. Like we say that the whole technical world is complex. And while it is complex or turbulent, it is because the degree of complexity has increased. And it is the job of the teacher, faculty members to see that how you can meet this particular standard. Question is, what do you mean by this particular thing, meeting this or meeting or rather helping these people? We talk a lot about the engineering while teaching to the students. But what is actually happening in the field, we are not worried about. And it's like in one class of the metal casting, I can finish the casting within 45 minutes of any product. But you see on a shop floor or in an industry, it takes days together to get that particular casting. So ultimately, you have to see that how your teaching is relevant to the deployment of the product. And there lies the skill. And this is where we have to look at. The 4.0, if at all it is to be defined in a very simple term, then they say that they use the cyber physical system and everything is fine. But there is a one important thing in the 4.0, that the product is to be manufactured without defect in first go itself. You can't talk about the defects in the product later on. So this is very complex, and there you will have to see that how best your theory is or your teaching is compatible with that. That's what many of those who are teaching in mechanical engineering, we teach the defects in casting to the students, and students take a lot of interest in that defects because there is a sure shot question in the examination on the defects of casting. Then I used to ask the student, why there is a defects in the casting when you have a manufacturing science with you? There is a science that is supporting the whole casting, and you are talking about the defects, welding defect, casting defect, manufacturing defect. That means there is some flaw that you will have to first look at. And if you can solve that, you should not teach defects in casting. There is no defects in casting. And the product is manufactured in first go without going back to the same process and defect free, and that's what 4.0. That's simple term. No doubt you can explain the 4.0 in paragraph after paragraph, but ultimately it is a defect free casting. Anyhow, now these are all the things talks about in industry 4.0, like robots, simulations, system integrations and all that. But out of that, out of that, this additive manufacturing plays a dominant role. Or rather, I should say that it is because of the additive manufacturing, industry 4.0 is in picture, or is in rather our discussion. Why additive manufacturing? Because you are already aware of that. We learn the subtractive manufacturing a lot, especially the machining and carpentry and all that. But here we say that we are adding the material and getting the part. What is the difference between the additive manufacturing and our conventional manufacturing? They say that it is the word called rapid prototyping. Now, they talk about the word rapid. Now, I don't know how many of you have seen the part manufacturing by this rapid prototyping. It takes almost 48 hours to manufacture that. If at all the part is given to the machine, 48 hours, 72 hours, sometimes 4 days they take to get that particular part manufactured. Then you start thinking about what is rapid in that. Where is the rapid? 48 hours is rapid, 72 hours is rapid. I think you'll have to think about it. What is rapid? You know, rapid doesn't talks about the time, but rapid talks about the in conventional manufacturing. When you use the human in being, he has to think a lot how to write a computer program on CNC machine, or if at all it is a simple lathe, how much feed is to be given, how much the depth of cut is to be given, and ultimately he has to think a lot while manufacturing that particular product. So this thinking process is removed in additive manufacturing. You have to get the 3D printing of the, that is a CAD model of the part, and simply send it to the machine. Machine will take care of everything. So there is minimum human intervention, and that minimum human intervention is linked to that rapid. Otherwise, I don't know how many of you have seen the die manufacturer. The die manufacturer takes days together to manufacture a die, and if you force him to give that product as early as possible, he'll say that I'm not going to give you that because I have to think over it, because it's a die. So here additive manufacturing is very important because there is a minimum human intervention, and one more point is that there are no tools. In the rest of the conventional manufacturing, you need a tool, and that tool takes a lot of time. If at all it is not up to the mark, it will damage the whole product also. In additive manufacturing, there are no tools. So this is one of the very prominent area in Industry 4.0. Now let me quickly take you to the another interesting point about the livelihood and education. This is a very common thing we are all worried about. You know, we are educating the people a lot, but at the same time we have to think about their livelihood also. Now I just written a simple word sentence there, focusing only on the livelihood. That is what you can see the picture in the so-called village. They are not focusing on education, only focusing on livelihood. That's all. Like whatever the work they are supposed to do to get the some to earn further, bread and butter. And there is an education that we are focusing more on the education. So focusing only on the livelihood and not on education leads to what is called as an underdevelopment. That means there will not be any development at all. But the question, which is $1 million question, does it mean focusing only on the education will take care of the livelihood? That means everybody is educated, and you'll say that okay, everybody is now comfortable, they are earning their livelihood. Is it possible? Now this is a very interesting question, and I know everybody must be thinking I should say no to that, I should say yes to that, and all that. So it's difficult to answer this question. Let me tell you an interesting thing here, that livelihood and education needs to be properly mentored. What is happening today, we are only talking about an education a lot, but not talking about whether it is linked to livelihood properly or not. And that's what exactly is the case if you see this particular picture, here, that if you are educated but not getting a service or not getting an employment befitting your education, then that leads to that is called as underemployment. There is nothing like an unemployment in India. Though we talk a lot about unemployment and all that, there is nothing like an unemployment. No one will be unemployed, because see, if somebody wants to eat, he will see that anyhow he will get that. But underemployment is dangerous. That means everybody is getting educated, but all of them are not getting their job befitting their education. That's an underemployment, and that's very problematic. So how will you like to enter into this particular domain, or rather how to tackle this problem? Because ultimately the problem is there, and you know, that's what I always used to tell my students. The engineers are there to solve the problem, and if there are no problem, the engineers will create the problem and solve it. So that's how exactly the case is. What is the solution to that? The solution is you have to focus more towards the research. That's what we talk about, a high-end knowledge. And here, when you talk about the high-end knowledge, that means you'll have to think about an innovation. So innovation plays a dominant role in Industry 4.0. All of a sudden the people talk about the startup. Some 10 years back, no one was in a mood to talk about this startup. But all of a sudden we talk about this startup. Why? It is because in Industry 4.0, they say that it is not the same product to be in the market, but it has to be innovative product in the market, because the customer is a king. Customer will take benefit of your work, research work. Okay. So innovative product. And there, when you talk about the innovative and tailor-made product, and if you look at the so-called the large industries, large players, they are not going to solve this problem. They are not going to help you in that, because they will focus only on the existing product. You can't ask them to innovate the product every now and then, but it is the startup which is going to help you. The startup will say, okay, this is innovation, okay, I will start my own company now based on that. And that is how the innovative product ecosystem will be developed by starting more and more companies. A very interesting thing about this Nandan Nilekini's speech, and I think this is rather the interview which I read it in Economic Times and during COVID. And then I have seen a very nice question asked to him, and his answer, I have written it here. He has been asked, you think the future for India will be where more small players will also compete? That was a simple question asked to him. He has answered it very nicely. He said, I am of the firm belief that it is not about few companies creating millions of jobs, not the large players like L&T and Tatas and all, not going to create millions of jobs, but it is the millions of companies creating few jobs each, where that's what I see as the future. So if there are more and more startups and everybody is creating few jobs, naturally our problem of underemployment will be solved. And that you can very easily see if you see the 2029 economic status, though the 22-23 is not available on the database. I had just marked it there, 4,70,000 jobs are created by 39,000 startups in a year. Yeah, no big players can create so many jobs. And now this is what is the power of a startup. Now coming to next interesting point about the deployment of research. But what I would like to tell you, what is the takeaway message of my first agenda, that innovation, thinking, means more thrust on human resources. That means human resources are not replaceable, because people are already disturbed. AI is coming, machine learning is coming, whether this job will be there or that job will be there and all that. Think about the mechanical job of a clerk and all that, that may get replaced, but thinking will be done only by the human being. I have not seen any news, I don't know if you have seen that, the robot which can only think for you, like what I should do in my problem in family, can I ask the robot? And the robot is solving your problem. So it's not possible, it's impossible. So here the thirst is on. So let us start with the deployment of research. This is very interesting. I am not talking only about the research, but I am talking about the deployment of research. That means how the research is to be rather used for the societal benefit. Here, what data speaks when you talk about the patenting in India. Though everything is given here, but I am worried about that 80% have that particular so-called the number. What is mentioned? 80% of the total applicants in your Indian patent system are foreign applicants. That means they are now coming to India to file their patent, so that their product is safe in India. They will manufacture their product in India, and finally they will earn the profit through that. I think this picture is rather very disturbing. We talk about Atmanirbhar Bharat a lot, but the foreign applicant is coming, filing the patent, and then they are establishing their credentials that this product we will manufacture here in India. Maybe so you have to be very, very careful about that. That means we have to also enter into the system of developing new product. Now, we are now entering into, or rather we are working in a metallic implant which is fitted into the patient's body. And it is a metallic implant. Orthopedic doctors, they generally talk about that. So as soon as they talk about the metal, then we say, oh, it's my job, mechanical engineer's job, because there is a metal, engineer's job. And he said, no, it's a doctor's job. I used to fit it into the patient body. I said, no, it is together. It is the job of an engineer and orthopedic surgeon together, how best this particular implant is to be fitted. Now I'm just showing you the picture here, that what are the metallic implants which are fitted into the patient's body. And there you will find that all these metal implants are very, very important from the point of view of treating the patient. Now let me talk about not only the metallic implant, but I am now changing that to metallic customized implant. That means talking about the implant which is fitted into the patient body suiting to his anatomy. Now when you talk about the customized one, that means now again I have shown you here the picture. These are all the hip implants which are fitted into the patient body. Now standard hip implant is available on the shelf, and you are fitting that implant into every patient is not justified. Because we'll say that my anatomy is different than somebody else, and you are fitting the same implant in my body, how it is possible? So, this is logically acceptable, but let us talk it from the medical science point of view, let us talk it from the engineering science point of view. Here, we have actually worked on the hip implant, and there we have noticed what are the different parameters which are noted in the medical literature. And that is what we have seen, that they talk about a various parameter called vertical offset, horizontal offset, anterior offset, neck angle, neck shaft angle and all. Now there when you actually enter into this, I'm just going to talk about one simple parameter, neck shaft angle, because shaft angle or angle is very close to us as an engineer. So what we have done, we have taken a study of 220 patients in and around Nagpur, that means in central India you may say. And what we have seen as a result, you can see it on the slide, neck shaft angle varies from 140 to 124. And that variation is also scattered. It is not that in the 123 to 124 most of the patients are grouped. Somebody is having 124, somebody is in 140, somewhere in 130, 132. So which one is the best neck shaft angle that fits to all patients? Then your answers will be no. I want the neck shaft angle to be fitted which suits to my anatomy. And you are an engineer, so naturally you will say 132.22, 132.324, something like that you talk about. Then if you tell it to the doctor, saying that please fit in hip implant which is having a neck shaft angle of 122.234. He said, what is that? That's not available on the shelf. What is available is 120 or 128. I can't fit you. Give me that one. That's not his question. If you are interested in the neck shaft angle 122.324, give me that. So it is again going back to the engineering. We have to manufacture that, and that's what we talk about, a customized implant. Is it possible? Answer is yes, it is possible. And that is possible with the 3D printing. And this is a very simple way by which the 3D printing is defined, that a CAD file changed to slice file, to which we call as an STL, and that you give to the machine, and there you will find that the part is produced. This is a physical model. So computer and directly the physical model, and that's how we also say that it is without human intervention and tooling. But interesting point about the 3D printing is that it can be clubbed to the CT scan or the MRI. And that's very interesting. And that is how the thing has changed in the medical domain, totally. Because computed tomography, to which we call as CT scan, is slicing. This particular figure must be known to you. Many of you must have seen it in the hospitals also. They just ask the patient to lie on this particular table, and that table goes inside the gantry. That means that particular hole, and just comes out and they say, ho gaya, CT scan ho gaya. Now, what exactly has happened in CT scan? They have taken a multiple X-rays of that organ. Otherwise, in regular or conventional X-rays, they take only one view. Here you take in a slices form everywhere. Virtual slicing and getting an X-ray. Virtual slicing, getting an X-ray. So it's like n number of X-rays. That's a CT scan. So what is that principle? Slicing. In your 3D printing, also you are using layering. So can you send the data from 3D CT scan to the 3D printing? Answer is yes, it is possible, and that is what is being done. And they say that, okay, here, if you go back, the CT scan image, to which we call as a DICOM file, that DICOM file you can convert it into the STL file by the various softwares which are available, like a Mimix and all, and directly give that particular part to the machine will build the medical model. Now, let me now take this one to interesting point, the hospitals in India and patient-doctor relations. Now, I'm just showing you the hospitals in India, and can you see this is a very disturbing picture, especially if you look at this particular doctor, he is disturbed, very heavily stressed, because he has to handle so many patients, and he is only looking at this, here, there, and all that. And I am more worried about a person here who is, can you see that person? That person is a small baby. He is also in the same room where the adults are admitted. And that is how the picture is. You will have to be more careful in this scenario. And doctors is required to handle this situation properly. So what happens, that these doctors get stressed, and finally, the cordial relation the doctor should have with the patient, that is not there. And what happens, that you fight with the doctors in India, that the doctor is not doing his duty, doctor is not doing his duty. Finally, it is all because of the heavily stressed situation. And many of you can ask the doctors who is working in a government hospitals, they are heavily stressed. And finally, we want to see that this is to be avoided. How do you do that? This needs to be avoided. How do you do that? Just look at this, a very simple, interesting thing. How to make the patient's-doctor relation cordial. I have shown some of the reports, like a pathology report, X-ray report, and the CT-MRI report. Now, as a patient or as a relative of the patient, if I am given that ye pathology report, dekho bhai. So I'll say, okay, here and there I'll see. And I'll ask doctor, sir, okay, everything is fine. I don't understand what is there. If you X-ray, this is an X-ray report. Are you okay with this X-ray report? So barabar hai na bhai, dekha sir, doctor, dekho, tumi dekho, CT scan. How many patients understand the CT scan report? And doctors is required to understand that. And if at all doctors does some problem because of which the patient faces the difficulty, we go and beat the doctors. Have you understood what exactly is the problem patient is facing? They say no, because we don't understand anything out of that. But let us look at an interesting thing here. Then there is a 3D printed heart model given to the doctor and based on the 3D printing, and the same model is given to the patient or patient's relative, especially in, I'm going to talk about that soon. So here the patient can also see, because it is a physical model, what has actually happened to that particular heart. And doctors can explain to him, see, this is a normal heart and this is the heart of the patient which is having a problem. Now you are convincing the patients properly. And now patient is also understanding how difficult it is for the doctor to operate that patient, if at all it is to be operated. And therefore, what is interesting here to see that the 3D printing plays a dominant role. And you can see here, the pathology, X-ray and everything makes no sense to him, but 3D printing model does that one. And therefore, what is important for us, that when you talk about the 3D printing in medical domain, such type of the fights will not be there at all. No one will beat the doctors, and they will say that, okay, sir, doctors, I understood, it's really tough. So this is what is required, and that is what we want. patient-doctor cordial relations. You know, if you go to a hospital, you should see that everybody is comfortable. Very cordial relation. Doctors are happy. Patient is also happy even if he is admitted. I think, I wish that such type of the picture should be there in each and every hospitals in the future. And that is true in developed country. When you talk about the developed countries, it is there. There they are so perfect in their treatment to the patient that whenever they wish to take even a pathology test, they simply ask the patient, should I take a blood from your body, because I want to test whether there are some problems, some infection in your body or not. The patient will say, no need to take blood. I said, okay, then I cannot do anything further. So to that extent, I don't know, here in India, first we give and they take my blood first. That is what. So they value the human being, and we need to value that. And that's how the thing is. You know, I can tell you a number of stories that way, but then I'll have to be more careful because I had to catch a flight also, and Pranav has to also. Anyway, that's one. So what is interesting here, I would like to quickly tell you about that. There is a technology called FDM. We call it the fused deposition modeling, and that's, I think, any of you, everybody is aware of that. So you can get a physical model of a medical organ directly from the CT scan machine. And now this physical model of a medical organ plays a dominant role in what is called as a surgical planning. I just introduce you in a quick 2-minute speech in the inauguration. But let me now show you these particular case studies. This is an interesting case study. I hope you will appreciate the importance of 3D printing in medical domain. Now this is what is called as the acetabulum. This is a fractured acetabulum. What is an acetabulum? You know, we have this joint called hip joint. So this hip joint fits into our acetabulum here, and that is a part which is attached to the upper body. Now that got fractured. It is not my thigh bone or my hip joint got fractured, but the acetabulum where this actually hip joint get fixed, that got fractured. It's very problematic, especially when such type of things happen in the accident. The doctor says that I will not operate this patient because the acetabulum is fractured, and that fractured acetabulum correction takes a lot of time, around 10 to 12 hours, because that needs to be properly looked at, and sometimes it gets fatal also. But see this case, which is very interesting, and we have done it in say 2011, we have published it, but 2007 we have done it. This is the 3D printed acetabulum fracture model given to the doctor. And the doctor, he has planned his surgery properly, that how to fit the plates there so that this will be properly corrected. Now, generally what happens, that the doctor is to think from looking at the CT scan and how exactly the plate is to be manufactured, and they just cut open the body and then start talking about their assistant 3 feet 3 inches का लगेगा, नहीं 4 inches करो, 4 नहीं 4.5 करो, but this is how they do it. You don't know what is actually happening inside the operation theater, and that's what I always used to tell my students. Like, have you seen any doctor coming out of the operation theater and simply showing that, oh, सब बिगाड़ दिया मैंने, खत्म हो गया, अभी मालूम नहीं जो भगवान है? Never. Whenever he comes out of the operation theater, he said everything is fine. God is there, you are there, I am there, everybody is there. So ultimately we start convincing. But see the problem of a surgeon. Once he go into the operation theater and he cuts open the body, he cannot simply say, "अरे बाप रे बहुत complex है, कल आ जाओ भाई." ऐसा नहीं होता. Never it will happen. And more the time he takes inside the operation theater, the people start worrying, why so much of time? Why so much of time? That means so much the stress should be over as early as possible. So you know, that's what exactly has happened here. He has planned the whole surgery by looking at this 3D printed model, and then he said, okay, this is how we'll do it. So he has performed it, and that's what I mentioned. Generally this operation takes 8 to 9 hours to finish, but he has finished it within 3 to 4 hours, and that's what he has saved the total 3 to 4 hours in the operation. Now that's less of an anesthetic dose, less of everything, and that's how one of the interesting point here, when you talk about the 3D printing is the surgical planning. You know, you talk to any surgeon, he will always say that the complex thing is planning of the surgery. Surgery is not a big issue for them, because once it is properly planned, they can do it very nicely. And 3D printed model actually helps them. And that's how we have published a paper based on that, which has got a lot of citation. But it is the perfect work where the Dr. Bagaria, he was our orthopedic surgeon, and myself, we worked together. And this is what an amalgamation of engineering and medical. And see, that's what I told you. Like, we are going to help the medical professions. It's not that I'm the surgeon now, I can do everything. And the surgeon will always look at me saying that, oh, Professor Kuthe, can we do this? Can we help? And that's what I told you in my introduction speech also. That the doctors, they start now relying more and more on the engineers who are using the 3D printing, and therefore ready to operate, even ready to take the complex surgical case. Otherwise, they used to say that, okay, I cannot do further. Okay. Now, interesting point here is that about this wonderful PhD thesis, which I have evaluated as a examiner. This is the work presented by the Guru Prasad Kuptura. And this PhD thesis was evaluated by me as an examiner. I found this one very interesting, very interesting. What it mentions about the role of 3D prototyping in visualization of the hard defect morphology and surgery. I will give you this particular thesis to you. You can go and enjoy that. This is very interesting. Let me show you an interesting thing here. This model talks about digital model and physical model. See the digital model and see the physical model. You yourself will find that the physical model is more appealing to you rather than the digital model. And that's what exactly is the case. He has shown so many cases, and that's how I can show you here his PhD thesis also, but I don't want to take more of your time. I don't know whether I can show you. Yeah, I don't know whether this is possible. Hopefully it is. Okay. Yeah. So let me tell you an interesting thing here before it gets loaded. That think of a newly born baby having some problem in the heart, and there are a lot of cases like that. And now that baby needs to be operated because of some problem. That's what they call congenital heart diseases. Now that small baby is to be operated. A baby of 1 month old, 2 months old. That's, now they say that we need the patient consent. Patient should give the consent for doing that particular operation. To whom you are going to approach? Are you going to approach the baby saying that karu ke operation? No. Then you have to talk to the guardians or the parents. Now, whether the parents will be in a position to give the permission, whether they know whether to grant the permission or not, he is not aware. You are going to show him the CT scan, you are going to show him pathology report, the X-ray, whatever it is. They are also confused what to do. And that's always been shown. If you don't give me the permission, I don't know what will happen to your baby. So this is what is the problem. But if you give him the 3D printed heart of the baby, saying that this is the problem in your baby's heart, just like going back to this is what I have opened, and there I will give you this thesis to you. It will be quite interesting for you to look at. So here, what I would like to tell you here, that this, I don't know what happened. Here. So here, if you give the physical model of the heart to the patient, parent or to the parent, then this is a problem. Then the parents will say, yes, it needs to be repaired. You please proceed with the surgery. And that is what is a very interesting thing. He has shown a number of cases wherein because of the 3D printing, the doctors also find it very easy to operate. Otherwise, it is impossible. So this is what is one of the major role 3D printing is going to play in the medical domain. And that is very interesting point. Okay. Now, let me take you in another interesting area, we talk about the implant manufacturing. You know, we have actually stuck up with that particular problem of manufacturing the hip implant having a neck shaft angle of 122.345. That's what you said about. Now, is it possible to manufacture? Answer is yes. That's how the whole thing is. If you look at this particular figure, there you will find that this is a CT scan, and then finally the RP, that is a prototyping, and then this is a model. You can use it as a pattern in case of a casting or any manufacturing view to get a metallic implant like this. This is the first model which we have actually fabricated in VNIT in 2006, showing that metallic part is possible to manufacture, which is actually mimicking the patient's part. So this has actually helped us a lot, and this is the first R&D project that we have completed that time, which we say that development and testing of customized joint replacement implant using layer manufacturing. Now here we don't want this cycle to be completed. I'm showing you the cycle, but we don't want this cycle to be completed because we don't want the healthy individual to become met with an accident to become a patient. But if at all it is so, then how you can see the thing changes? You take a CT scan of that, get a computer data, and use the medical CAD data where you can actually get the so-called 3D printed part of the metallic implant to be manufactured using rapid prototyping, where you can set the angle to 123.345, the one which suits to the patients. It is possible because once you have the CAD data with you, you can change it very easily, the model, based on the patient's anatomy, and finally give it to the rapid prototyping system to get the model, and finally use the casting simulation. That's what we have tried our best to get the perfect casting, and finally the part which we call it the customized part is possible to fit into the patient body, and this is all possible because of the 3D printing. Otherwise, on the self only 120 degrees available, 128 degrees available, not 122.234, the one which you talk about. But yes, with 3D printing it is possible. Let me tell you about some of the interesting case studies that we have completed. What we call as the unmet needs. We have developed the customized implant, and these are the 3 implants which I am going to show you quickly. And there, one of the very nice studies, the temporomandibular joint of this particular girl. This we have finished in 2007, published in 2011 in Laboratory Journal. You can see here this particular part we call it this is called as a temporomandibular joint. You know, with this joint I can open my mouth, I can change that anything. It is only because of this joint. This is called as the temporomandibular joint. Now, because of the accident, that particular joint has been, she met with an accident, and therefore that got fused. You can see here this is a fused one, and she was not in a position to open the mouth. Now, she was on a liquid diet for the 6 years, and because the doctor was not in a position to fit the joint properly, and she approached to one of the big hospital in Nagpur, and that doctor approached me and saying that, Professor Kuthe, can we develop a metallic implant for this particular patient? And he has shown me some paper from the Brazil saying that this is possible there and all that. So I said, okay, what type of a joint it is and all that. We were thinking a lot. Then I said that, how I was thinking from the manufacturing point of view, like how it is to be manufactured. So I was just asking like what type of a joint you want. So he said something like this, then there will be some ball here, got me something. I said, can you draw it on a paper? Because drawing is important to us as an engineer. Can you draw it on a paper? Drawing. You know, the asking doctor to draw something, his handwriting is so poor, and I'm asking him to draw something on a then I said, no, better don't talk about that. And immediately recalls me that is, why not to give him a clay? And you know the clay, these two, your children, they play, no? I just given him the clay, and this is how he has done it. Can we do this type of implant? I said, okay, now I got what exactly you want. Then I reverse engineered it. N number of permutation combinations we have done, and finally this joint we have manufactured, fitted into the patient body, and finally you can see that she was in a position to open the mouth. Let me tell you an interesting thing here. Maybe you will enjoy that. the doctor was very, very happy with this particular operation. And he said, sir, Professor Kuthe will call the press and we'll tell them that this is done by me and all that. I said, great, call the press. So it was press conference was organized, and that is the first time I came to know how to make the press conference successful. What you have to do, you have to arrange a very good refreshment on a table. So as soon as they enter, they will look at the refreshment. Sir, kya likhna hai batao? I'll do. So there was in that particular press conference, we kept up samosa, which is very popular there. So, and this girl, she was from Rewa, that is from MP. And she got excited to see that particular samosa, which she has not eaten, taken a bite for the last 6 years. She was on a repeat diet. So she was looking at that. So we just asked her, would you like to take a bite of that? She said, yes. So when she has taken the first bite of the samosa, the satisfaction I have seen in her eyes, and the satisfaction I got, I never got that satisfaction after my marriage, after my promotion, after my getting all the PhDs and everything. Because there we realize this is how you can serve the society. This is very interesting, the thing that has happened. And then we are done a lot of work in that. I will show you quickly about that case study at the end. But then another one is the customized metatarsus joint implant that also we have fitted into the patient body, again by using the same methodology, and now even using an ANSYS, test the product perfectly and all that, and we have published this. So you can see that one in our case study. Then this is another one about the maxillofacial joint. Again, these are all customized joint. That means not available on the shelf and possible only with the 3D printing. Otherwise, if 3D printing would not have been there, these operations would not have been taken place. There would not be any deployment of any work. So what exactly in my second so-called point of the agenda, you may say, sir, our 5 bache hain, jaldi karo, the lunch is approaching. Yes, I am doing that fast. But then deployment of the need-based research is deployable, so identify the need. So that's how the case is. If that doctor has approached me saying that we need to develop a pain plan, so therefore this has been developed. So deploy need-based research is important. Otherwise, simply doing the research just for the sake of doing research makes no sense. So that's what exactly the case. So this is a Charles Goodyear, maybe a very famous scientist. Goodyear tires, you are aware of, is it not? So he's a person who has developed Goodyear tires, means rubber for the automobile, and Goodyear tires are very famous. It's a very interesting story that goes with him. When he was actually working on a rubber, he was worried about how to use this rubber for the automobile. Because the automobile works in a field where the temperature goes up to 55 sometimes, and then that rubber gets melted. So he was continuously working on a rubber. So in his lab, what is his lab? A simple small so-called room in his so-called house. It's not the lab that we do have here like this. So it's a simple room and continuously working 24/7 on that. So luckily or unluckily he was married. So his wife one day came to his so-called lab and then asked, he started shouting at him, what you are doing, all nonsense thing here, not coming to my home, not looking at my work and all that. And then that pan where the rubber was boiling, she just simply lifted it and threw it in the corner. All nonsense work. And his lab was not organized. There on the so-called corner, sulfur was lying. So this rubber started interacting with the sulfur, and Goodyear started, something is happening here, let me see. And that's the vulcanization of rubber, which is used nowadays. So that's great. I tried to fight with my wife n number of times, but I could not do any research. So this is how the research that goes there that time. But this is how the thing should be looked at, need-based development. What was the need? The rubber to be developed for automobile. It's not that the rubber is invented. No, you have to think about the need. So now let me talk about quickly about our 2 projects and BETIC VNIT. So here in this project BETIC, we talk about R&D project. Can you see that the R is small and D is big? So we don't talk about the research and development project. We talk about the research and deployment project. Whatever the research you do, whether it is deployed in the society or not, whether the people in the society are getting benefit of your society, that's not exactly the R&D project. So here, I'm happy to tell you that Dr. Anil Kapoorkar has inaugurated our Betik Center, and we are doing a lot of work there. Again, as I already told you, you are invited to see our work. Here we are actually working on a bone tissue engineering. That's something which is next level of the 3D printing. And we are trying our best to develop not only the metallic implant, but the metallic implant which is porous. And not only the metallic implant which is porous, but the implant which is bioabsorbable. So, that's how the thing is. There are n number of problems that goes with the metallic implant, and here I would like to quickly tell you the same so-called cycle, but here I am using the 3D bioplotter. So we do have a 3D bioplotter, which is an extension of the next logical step of the 3D printing, and there we are using to develop it for developing a scaffold. Pranav has worked a lot in that. He will definitely tell you more about it, and therefore I am just showing it in the form of a tree. It's like a orange tree, because orange is very famous in Nagpur. So whenever you'll come, I'll see that you will enjoy that. But here we talk about the tree Betik VNIT, where we ask the students or the innovators to come and sit on the tree, so that they will work hard, and there will be the flowers which will blossom in the form of a startup. And these startup are for the innovative medical devices, which is in the form of a orange fruit, which will be plugged by the people in the society as under the Atmanirbhar Bharat ladder. And all this is possible because of the sun, which is Betik IIT Bombay. So we are together in this particular Betik VNIT. Please do come. There is a selfie point here where you can take your selfie there and see what exactly we are doing. I'm happy to tell you that we also worked on a theme called Engineer Your Research for Startup. That means we say that whenever you do any research, see that it is deployable. That means you should start a company. And whether you do file a patent, whether you make some research, or whether you get a PhD, see that ultimately it should end with a startup. And I'm happy to tell you that Professor B. Ravi is a mentor of our all work. I am closely associated with him for the last almost 20 years, and he is guiding us very nicely. He is presently the director at NIT Suratkal, but he has talked about what is called as the golden spiral or the reinvent. He said that research, education, innovation and entrepreneurship should all go together, and therefore the teaching faculty should not only talk about the academics, but they should also talk about the research. They should also talk about the innovation and entrepreneurship. Then the students will blossom. That's how the thing is. See, the simple case studies which I have shown to you of a customized implant. When I teach the layer manufacturing to the MTech students, then I used to tell them, okay, let me show you some of the case studies that we have handled of customized implant, that is an application of 3D printing in medical domain. Now students start looking at every case study thoroughly. Now if I will teach them the same thing again and again, which is already available on the net or everywhere, the people will say that, okay, ये सब मालूम है, इससे तो better वो MIT के professor देता है, भाई उससे ले लो. So but this type of the things makes some sense to them, and that is how we like to look into it. The BIRAC grad, which is very, very popular, I am happy to tell you that these, we have been successful in getting this BIRAC grad. See, Dr. Sandeep, Neha and Dr. Pranav, all of them have actually completed PhD in this CAD/CAM center, and they have started their own company. Happy to see that Dr. Pranav is here. He will talk more about that. Then what is a so-called take-away message from the Betik VNIT is focused on multi-institutional and multidisciplinary research. Multi-institutional, that means now we are working with IIT Bombay, therefore it is very easy for us to get the work done. So it is not only one or two, but maybe n number of things should be there. Then multidisciplinary. Ours is a highly multidisciplinary, engineering and medical together. So all these things will help you. Now quickly about the smart foundry. This is the manufacturing project that we have completed. So here this smart foundry, where we talk about not the smart as an English word, but it is actually the expansion of what has been indicated, that sustainable metal casting by advanced research and technology. That means how we are going to use this 3D printing in manufacturing. So let me quickly tell you about that. The medical devices classification, everybody is aware of class A, B, C, D, and even the 1, 2, 3, what they talk about international level. So high risk devices, especially class C and D, are very important. Most of them are imported, and therefore when you talk about Atmanirbhar Bharat, we have to focus on such devices which are imported. And like the metallic implant I talked about, it's a class D device, very high risk device. You are manufacturing in India, giving the benefit to the people in the India. That's what is an Atmanirbhar Bharat. Okay, we have presented these case studies on a number of platforms, including at MIT, Harvard, and the Cambridge, and many universities abroad. I found that the people cannot cross me saying that why you have done that, this is a wrong thing. Though they have tried their best to tell me that what is to be done if at all this fails and all that. So I used to tell them, like in medical literature, they say that if you operate a patient, the patient will die. If you do not operate the patient will die. What you will do? So in that case, the only answer is we will operate the patient, will develop a case study, and we'll see that how to take care in the next case, if at all he dies or she dies. So what I would like to tell you here is that if you simply, they say that if your tongue gets burned by sipping a very hot milk, then even the buttermilk also you should see that it is properly taken. I said properly taken. That we have to take the buttermilk. Otherwise, simply saying that buttermilk is there, I'll not take, only go on thinking, that makes no sense. Exactly is the case. That I've already told you, doctors are ready to come forward for even a complex surgery just because of the 3D printing model. Yeah. So what I would like to tell you here, that the surgery is important when implant is to be fitted. And there, when you have the choice of the imported implant and the so-called Indian implant, which I am showing you, the doctor is confused. Like if you tell him that which implants to be fitted, imported or the Indian, the doctor will say, tell me which you want. Then the patient will say, jo tum bolenge wo, whatever it is. So ultimately he is confused. So what is interesting here, that these orthopedic implants to be manufactured in India, they should have the quality same as the imported implant, and that is what we will have to say. That means what? The implant has to be defect free. Number two, then the doctor should have a full confidence in your manufacturing processes, to which we call it the good manufacturing practices. Then this is what is possible in smart foundry. We have actually shown this by this particular slide, where the design process simulation is done using 3D printing. The pattern is fabricated. Then that when we used properly by using the melting and process in the gravity casting, and finally by using post-processing, you can see the complete display here. That's what we talk about the smart foundry. I'm just telling you quickly here because I wish that when you will come and see our facilities, you will enjoy that. This is what they talk about, the complete metal casting, but you can see only the last line. There it is mentioned, adding intelligence to manufacturing using cloud, big data and analytics. So use of AI in mechanical engineering is the case here. So that's what I told you here. IT-fying the mechanical engineering is important. Otherwise, the people talk a lot about AI and ML and all that. But if you ask them, can you give me any success story of AI and ML in manufacturing, then they don't have, other than the weather forecasting. Because weather forecasting is the only where there is a data available which is reliable. But then you don't have the data, you can't think of only, or you can't talk about the AI. But that's what exactly one of the very nice things we'll have to develop in manufacturing sector, that the product that is coming out is flawless, without defect, and that's possible. So what I would like to tell you here, the silent points are that we use the 3D printer, we use the simulation software, we use the automation in mold preparation, data analytics, and finally 25 by 25 by 25. You said, what is this 25 cube? This 25 cube, let me quickly tell you about that. Though this 3D printing and everything I already mentioned about, then I told you about how this particular case study is to be done. The simulation softwares and all that things is very important. I don't want to take you further with that. But let me take you about the 25 by 25 by 25. Here what we say, a 25 years engineer having a 25 meter square area, having a 25 lakhs as the financial resources available, should be in a position to start a company which will show the feasibility of the innovative product, and that is what he is creating, what is called the job. So we have to create such jobs, innovative, just like the customized implant I talked about, and it has got a tremendous application, especially when you look at the last sentence, serving the needs of medical fraternity in semi-urban and rural sector in India. You know, in rural sector, I have also seen very good doctors, very intelligent doctors operating. They have wonderful idea, but they can't rather take that ideas to deployment just because there is nobody to take their ideas further. But such type of the things should be possible everywhere, that let the ideas come from the doctors, we can manufacture that implant, deploy it in the patient, and see that everything will be quite possible. There is 3D metal printing we talk about, and you know, the smart foundry is the very good alternative to that. We have tried our best to see that. I don't want to take you further with this. But what is interesting here is that the 3D printing plays a dominant role, but so is the case with the smart foundry as equally, which is cost effective, especially from the developing countries like India. Now, what is the takeaway message of the smart foundry? It's like a focus on job creation through advanced technology and sustainability, and smart foundry as a substitute for the 3D metal printing. So finally, the conclusion, we may call it the Bhairavi Rag, to see that everybody is comfortable that here I can say it in some points like innovation is defined, deployment of research is explained through case studies. Then I had told you, let's start up as a PhD spin-off. I have showcased smart fund introduce the solution to underemployment, and challenges to upgrade researcher to do research which is deployable. I think this is to be marked as a so-called the red letter, that whenever you say that the research is done by a student or by anybody, you should always ask him the next question: are you deploying this research or not? Okay. So let me tell you an interesting thing here about the Dr. Chittarajan Ranawat. I don't know, I think you may be aware of this doctor. He is an orthopedic surgeon, and he has operated the knee of Dr. A.B. Vajpayee when he was the Prime Minister of India. He was called from US and asked him to do that particular surgery. I'm happy to meet him in Florida, and what I have seen that he has around 25,000 citations and a lot of research papers. But interesting thing is that when he was seated as a judge for the evaluation of the research, he used to talk in that sense. Okay, this is not correct, whatever you are saying. Please refer my paper which is written in that particular journal. This is not correct. Refer my paper there and all that. I was stunned. I said that he is aware of every research paper that he has published, and he is to guide the people, researcher, that okay, you are going wrong here, better do this way. So it's not only where you are going wrong, but it is the mentoring the researcher. So it was wonderful. A lot of papers he has published. The another one is the Robert Langer. I think he is a MIT professor who is very successful as a tissue engineering person. And you know, his interest point is like he has more than 1,000 patents. But what is interesting that he has founded more than 20 startups. So see this change from 2011 to 2024. 2011, everybody was talking about the research papers. And now 2024, they talk about how many startups you have rather mentored or you have started. So research profile is to be evaluated from, I have 1,000 papers published, but if I don't have any startup, that research papers has no value. So this is how the thing should go, and that's what I say, research plus deployment. I don't mean to say that the research papers are useless. Research papers has to be there, but are you deploying that research or not? And that is what you can do it by using the pen. So finally, this is the happiest moment for me to show you here that temporomandibular joint that we have operated in 2007 fitted into. I'm happy to show that in 2022, the same lady, now she is married now, and now you can see that she visited Nagpur, and the doctors called me, Professor Kuthe, will you please come and see her? I said, okay, and then when we have asked her, oh, how are you? She was very shy, and then I just asked you, can you sing some song or not? She said, sometimes I sing. I said, how? How do you sing the song? So simply she said, ah. I said, great, you are doing well. That means because I want to just see whether she can open the mouth properly or not. What I would like to tell you, that's the happiest moment. With that, I should say a big thank you to you for listening to my lecture. And I'm happy to answer any questions that you would like to have. I think I have taken more time than given to me. It's 1 hour, yeah, thank you.
Thank you, sir. Thank you for your time. It was not at all a long time. Actually, it was still short. I thought it would have run more, half an hour more.
I think so. Brother is looking at me continuously.
So, any questions from the participants? Please, you are free to ask any questions which you have. Okay.
Yeah, I'll be happy.
Sorry to interrupt you, sir.
Yeah,
My name is Chandrasekhar from CBIT. I would like to ask you one question.
sure.
Whatever the metals or bioimplants we used,
Metal.
bioimplants we used for body parts to replace.
You meant to say material. Material used in that.
Yeah.
That's great.
That material,
Well, yeah.
my question is, whatever the calcium inside,
Calcium.
bones, whatever we call bones,
Yeah, when
the bones material property and the bioimplant material properties may be vary.
see, when you actually feed the metal into the patient's body, it's a metal. There is nothing like a rather matching of that with the bone characterization. It's a simple metal like the three metals which are compatible. One is stainless steel 316L, another is cobalt chrome alloy, and third one is the titanium alloy. These are the things which are accepted by the FDA, that means by the government, and you can use only these three metals. Out of that, the stainless steel 316L is more preferred because it is not very costly, but titanium is a bit costly. But with the 3D printing in the field, nowadays the people are using titanium also. There is nothing like the how to mimic the bone in that metallic implant. You can't do that. It's impossible. But there is another problem. Like when you feed the metallic implant into the patient body, then there is a phenomena called as the stress shielding. That means now if you use the metal implant into your hip joint, the whole load is taken care by the metal and not by the bone. And that is a major problem because the bone is not subjected to the load and the metal is subjected to the load because the Young's modulus of elasticity of bone is less than that of the metal. So what happens, like the bone is resorbing. What is resorption? You start resorbing. That means it is not developing. If it is not developing, that metallic implant becomes loosened. And that's what they call as the loosening of the implant. And there exactly we talk about the tissue engineering. We talk about the metal scaffold. So we want that the bone should go inside the implant, and there should be actually a combination of the bone and the metal, so that the most of the work, load will be taken care by the bone and metal together. So it's like approaching the density of the metal and that of the bone together. That's how it goes in the tissue engineering, different topic. But metal is metal, bone is bone. There is nothing like you can compare like what is the characterization of bone and characterization of the metal. And therefore, the one of the interesting point here that you will have to note, the metallic implant is always taken with a pinch of salt. They say that we are fitting the metallic implant into the patient body, but doctors say that it is for certain years, 10 years life is, 20 years life here. You may have to go for the revision surgery to put the one more, and because it get loosened. So metallic implant is not a permanent solution, but yes, tissue engineering will be a permanent solution if you can develop a bone implant, and that is how the lot of work is going on, research work is going on. They are thinking of organs printed in lab. They say that the organ will be possible to print in the lab, and that's a wonderful so-called solution to the organ transplantation. So, the day is not far off when you'll find that the many developed countries, hopefully in India also, that the organs will be developed in plant, and there are a number of less donors and more acceptors of the organs. So that problem of less donors and more acceptors will be solved only by tissue engineering.
Sorry to interrupt you, sir.
Yeah.
But I heard some microbiology about it. They collect the bone samples. According to that, they will manufacture the same tissues, same biocompatible materials for the particular patients. But it's a costly effect. Costlier.
You mean to say
Sir,
taking a tissue and manufacturing?
no, whatever the bone broken, okay, if you want to implement metals instead of bones, that bone samples being collected, they send to the biomedical or some microbiologists. They will develop their own material
Yeah.
for the body. Here, my doubt is why I ask you those two materials is whatever the materials they developed, we are unable to print.
Develop the material unable to print.
Yes, whatever the
3D
materials,
printing, you mean
yeah,
to say?
3D printing. That's the issue we are facing right now.
I think I'm unable to talk about that because in 3D printing there is a restriction that what materials to be printed, and we do have in metal 3D printing also only the stainless steel and titanium and aluminum powders available, and unless you have any raw material in a powder form, you can't go for the metal printing. But yes, FDM will use it just to aid us in our manufacturing of as a pattern, and then finally again going to the conventional manufacturing route. So I'm not aware of that, like what you said. But even today we talk about the tissue engineering a lot. But the gold standard is metal implant again. Even in US they say that okay, gold metal is to be fitted, not the tissue engineer scaffold and all that. It takes some time to accept in the by the government all over the world.
Thank you, sir.